Previously, we have looked at the concept of ISA. Remember, ISA is both a proactive and reactive process. So you must remember all the steps that is required in an ISA process. And also remember, in planning in the ISA, we need to have both the management and also the enabler to sit together in order to come up with a proper planning for the ISA. So for today, we are going to look at part 4, the Security System Development Lifecycle. What is it? The Security Software Development Lifecycle, or the SEC-SDLC, in the first time you may find it somewhat different in several specifics of the steps. But once you get to know each of the steps, you may find that the overall methodology is somewhat similar to the traditional SDLC, but it focuses more on the security part. So the SEC-SDLC process involves, first of all, the identification of the threats and also the risks that may come to your asset. Remember, ISA is a proactive process and both a reactive process. So you need to first of all identify the threat and the risk before it actually comes to your asset. So you must anticipate what will come to your asset, what are the possible threats that could actually harm your asset, and then what risks could come from the threats that actually harm the asset that you are trying to protect. So basically, you need to follow all the steps throughout the SEC-SDLC, meaning from the investigation, the threat modeling, analysis, logical design, physical design, implementation, and maintenance. And basically, this process can also be in a cycle. It means that, let's say, after you actually implement and you maintain all the implementation, you may find that perhaps after a year or perhaps half a year or perhaps after an incident, you need to rethink again or investigate whether the threat and risk that you addressed previously could perhaps be fixed or be improved to enable the risk and threat to not actually harm perhaps your clients or perhaps your brand in the next coming year. Now this is a close-up of the diagram for the SEC-SDLC. So again, we look at the investigation phase, the analysis, logical design, physical design, implementation, maintenance, and change. And basically, remember that this process is actually in a cycle. It doesn't end once you get to the maintenance stage. Basically, maintenance means that you always try to monitor whatever happens next to your implementation. So if anything happens to implementation, perhaps there is perhaps the opinion of your perhaps implementer or perhaps your client, or perhaps there is an incident that happens that perhaps you cannot anticipate during the investigation, then you return back to the phase and begin the process all over again. So the deliverables of this thing, okay, now we look at it. So during the investigation phase, you see that you need to look at all the process, outcome, goals, scope, the cost, benefits, budget, and constraint, and also the development specification. It means that during the investigation stage, you must see and sit together with your team and see the current existing process. What are they? And then see all the process, whether it actually connect with your goals. And then see the scope of the process, what does it cover? And then the cost and benefit. So let's say you want to implement something. What does the cost actually means to your company? And then let's see, if you invest a certain cost, what are the benefits? And then let's see, during investigation, you perhaps think about the constraint. Currently, financially, where is your company at? Can you actually maintain the current process, or some of the current process can actually be put together or be combined or perhaps be terminated altogether? So during investigation, you consider all of those things. And then you see whether your development team, what are their specifications. Let's say during investigation, you say that perhaps we want to do certain things, okay, new in the next current financial year. So can your team actually do it? Okay, what will it cost your organization? And then followed by the analysis. So the analysis will deal with the issues with the current program or system. So after you investigate, you identify the current system, you identify the environment, meaning in the current system, what does it cover? Who is the people that is using it? And let's say you want to actually upgrade the system, what will be the requirement of the new system? This is very important because usually during migration, you need to see whether you have the backup of your current system. Let's say you are in a banking system. Of course, if you want to upgrade, you need to have a certain downtime because you need to actually perhaps update the software or perhaps update the hardware. So you see what are the issues that will actually come if let's say you want to do an update or an upgrade to your system. And then you look at the next phase, the logical design. So the logical design will always follow closely to the analysis. So the output is you need to come out with the general system specification or the blueprint. So this is where you think of perhaps the system flow, the design, what perhaps new interface that the user will actually use, and then who will be actually using your new system that you are actually implementing, and then what does it improve. Let's say you are actually considering a new interface. Will it be easy to use, or who will be testing it before you actually release that particular design? And then the next is physical design. So this is actually the detailed program specification including resource and personnel. Who will actually test this? Who will actually use this? Will the people understood once you actually put it in actually execution? And then implementation. During implementation, you want to have feedback. So you want to see whether perhaps your beta tester or perhaps your first phase user actually understood that what you have in design or what you actually during your implementation, what you want is actually what the users can actually do. And then of course, lastly is the maintenance and change. So let's say after the feedback, testing and system acceptance, so the next step is actually to see the performance and operational reporting. Of course, like any system, you always get feedback from your users. Or perhaps there is a certain policy that you are actually implementing. So you see whether you have users complaining or not. Okay, and then how smooth does the new system compare to the previous one. So you need to actually collect those data to actually, after that, rethink again for investigation, let's say after the new cycle. Let's say for year 2020, so you implemented this thing. So by the end of 2020, you need to actually investigate again. For 2021, is the previous implementation still relevant or can also deal with the threat and risk that is coming in 2021? So again, remember, RSA is a proactive and reactive process. Proactively, you think about what is coming. Reactively, you think about how to react or how to actually address the problem that is coming based on what you already implemented or anticipating. Now we look at all the phases individually. So first of all, we look at the investigation in the SAC SDLC waterfall. So basically, this phase always begins as a directive from the management. So let's say the manager says that perhaps there is some of the process that needs improvement. So they call for a meeting, sit together, and actually see all the process one by one. So basically, it frequently begins with the affirmation or creation of security policies. So policies is actually are the directive or the rules or the things that you actually follow within an organization. Means, for example, how do you come to work? So how do you come to work? Usually you have to come within a certain time, let's say 9 a.m. And then what you need to do to actually record your attendance. So perhaps you have a punch card system, or perhaps you have a tag, or perhaps you key in your ID on the door. So after that, how long do you need to work per day? And then what time can you actually clock out? That is one example of a policy. And then another example perhaps is how does a customer actually register for a new purchase, right? So those are the examples that can be actually translated into a policy that all the people understand and follow. So by looking at the policy, they will try to look at perhaps in the policy or in the execution of the policy, is there any weakness, or can we actually address certain problems? Can we address people that are perhaps cheating, or perhaps can we address people that are actually wrongfully manipulating the policy? So they sit together and study the policy again. Perhaps an incident happened, and perhaps a customer cannot actually do a purchase or cannot actually record his or her purchase. So where does the problem lies? They look at the policy first and then look at the actual existing implementation of a user's purchase. So basically the teams assemble to analyze the problem, define the scope, specify goals, and identify the constraint. If you look closely, this is actually similar to every project planning, just like your FYP planning. So during the investigation is similar to that particular process. You have a team assemble, you analyze what are the problems that needs fixing or improve, you define the scope of your fixing, meaning let's say that particular system, which department does it fall, or which particular module in the system that actually handles that particular event. And then you specify the goals of your improvement and identify the constraint. So perhaps the constraint is perhaps you don't have enough budget, or perhaps you don't have people that can actually address the problem, so you can actually import other team members from other teams. And then you look at this phase is a feasibility analysis, whether we have enough resource and commitment to actually do the actual implementation and improvement later on. Feasibility analysis is important because you will see financially where does your company stand. Do you have enough resource? Do you have enough people or not to actually do it? Perhaps the reason why there is a problem is because you don't have enough people. So you can address that particular problem. You need to do more hiring perhaps. Or perhaps your people are not skillful to actually develop that particular module. So you need to send your people to perhaps a new workshop, course or training. So this is why investigation phase is very important, and you need to be very honest with your people and your organization. What you can do, what you cannot do, perhaps is the reason that there is a problem in the first place. In analysis, we look at the threats and associated controls that you can actually or already implemented. During the preliminary analysis, you look at currently what have you planned previously or what have you implemented currently during the crisis or to handle the crisis that perhaps is coming. So you look at the known threats and what are the controls that you have to actually address those threats. You look at it and perhaps you also look at the problem. So perhaps your current control cannot actually handle a newer threat that is coming, or perhaps the incident happened because the controls are not properly implemented. Because sometimes you have proper control, but it's not implemented properly. Perhaps you have a problem in your people. You have a problem perhaps in the execution. So you look at it again. You analyze one by one each of the control that you have. Does it properly address or does it properly being executed or not? Who is actually the implementer? Who actually keeping records? Who actually keeping tabs? Okay, and then is the report that you receive is actually true or not. And then you also begin risk management in this stage. So because you have threat, you also see whether if that threats keep on coming to your asset, what are the risks to your company? Let's say the threats is affecting the operational time of your organization. So of course, the risk of it, your client might not believe in your brand anymore, because usually when they want to use your service, let's say you are a bank system, your service is always down or unexpectedly. You didn't plan for a downtime, and then during that time your client wants to use the service. So this perhaps will affect the trust of your client to your brand or your service. That is one part of the risk that you need to actually manage. So that's why risk management also begins in this stage, because threats and risks are always relating to one another. So you also look at relevant legal issues that could affect the design of the security solution. Let's say you want to actually upgrade your system. So legally, let's say your client will want to use that particular system during that particular time. So let's say unexpectedly your service cannot be provided to your client. So can they actually sue you because you don't provide the service that you are promising? Or perhaps some of their information is leaked because you didn't properly address the threats of data loss. So you need to again see the legal issues with your associated control. Is your company covered or not? Is your client protected or not? If let's say the data loss is happening, can you protect your client? Or can you protect your organization? You need to see both through a legal issues and legal eyes, because you want to also protect your company. At the same time, you also want to protect your client and the asset that you are handling. Next is the design in the SEC SDLC. So we have logical design and we have physical design. Logical design means that your team member create and develop a blueprint, a design, a flowchart, for example. And then how will the user react? Perhaps there is a use case in the logical design. How many modules does you have? And then for each module, how do you actually protect each module? Who will handle each module? How will the user use it? Okay, these are the things that you need to look at in the logical design phase. And then the physical design, team members evaluate the technology. So you have this thing in theory that you want to have. Physically, in the real world, this is actually what you have. Perhaps you have this particular server. Can you actually handle multiple users, thousands of users at once? Because that is what you want to do in the logical design phase. And also, we see alternative solution. Let's say logically we have designed this. It's the very best of design, but physically it is not feasible because we have certain constraint. Our server is not powerful enough, or we don't have enough people to actually maintain the server. So we must have a in between the two, between the logical design and the physical design. What is the best solution that we can have with the current constraint that we have? So before you actually begin the physical design phase or implementation, you need to see, okay, logically you want to have that in the design, but physically that is the only thing that we can have. So we need to go again to your users and then see what are the requirements, whether within that constraint you can have perhaps 50% of what you actually want to implement is there, and then your users will be happy about it. In the design phase, there are three categories of control. You have managerial control, operational, and technical. Managerial is designed by the strategic planners, meaning the top management will actually design a certain policy that must be executed by the admin of the organization. Operational wise, it covers the management function and lower level planning. So let's say you have this certain policy, and then you have a certain thing that you need to be implemented. Let's say an attendance system. So who actually will actually monitor the attendance system, who will actually using the attendance system. And then also, let's say a certain data is lost. So you need to have some disaster recovery and incident response planning, as well as personal security, physical security, and the protection of production input and outputs. So these are examples of operational control, meaning for the running of the things that you have planned, who will actually monitor or who will actually use it. So you have a plan, you have the managers, and these are actually the implementer. And then the technical controls. And this is basically in the hardware and software part. So use this to implement security in an organization. You must think about how do you integrate the policy that you have planned, the rules, or how do you actually do purchasing with the client, for example, and then how do you translate those policy into the IT structure, meaning programmatically, how does those things work, how do you implement the rules, how do you actually implement the law, what can be done, what cannot be done, who is the user, how many access level will you have. So these are the things that you need to consider also during the design phase. You must have the managerial control, meaning the policy. You must have the operational control, who will actually be managing those things. And then the technical control, how to translate those policies and process into the software and hardware. After you finish designing all the solution that you want, meaning you have the proper policy, you have the proper people you think about, you have already all the technical know-hows, all the capability, now you actually want to actually implement. So you already have the security solution. Now you want to have it tested, implemented, and again, tested it again. And then let's say the implementer, the personnel, or perhaps the user. These are the things that you are evaluating. Does your people need specific training? Or perhaps your users. You need to actually train your users before they can actually successfully understand and use the system. So what are your training module to implement or to enable your users to use the system? Even your people. Do they understand how to actually use and actually troubleshoot the system? Because once you deliver it, of course you have some people maintaining the system. And then the most important element is the management of the project plan. Now you actually want to plan the project, supervise, and also wrapping up the project. Because actually you have the solution there, you also need to address the personal issues and training. You also need to address in the long run who will actually be using the system, how you actually will do the patching, how do you actually do the migration. So these are the things that you need to actually consider for the implementation phase. Now the team to implement your information security project can be different individuals, consist of these characteristics: the champion, the team leader, the policy developer, the risk assessment specialist, security professionals, system admin, and of course the end users. The champion is usually the people that is overseeing the project, and then usually they answer to a higher management. So the champion will actually assign the team leader. So the team leader will actually manage the overall process and report back to the champion. And then the champion will report back to the top management and tell them, okay, that the thing that the management want to actually implement is on its way. Of course, you have to have the security policy developer, meaning who is making the rules and regulation based on what the management is wanting. And then see the risk assessment, meaning let's say the threat is this one, you have possible data breach, or you have people that will steal your data, a hacker perhaps, and then the risk is that perhaps your client data will be lost. So we'll see also the security professionals who are actually handling those incidents once it happens, and then the admin who will be actually managing your system in terms of hardware and software. How many access level will you have in the module? How can you manage the user? how can you actually monitor the people going in and out of your system. So these are examples of the team and what they need to do within the information security project. So once you have a project that you want to implement and develop, so each organization should examine the option for staffing. Meaning, let's say you want to develop your module. So do you have the people within the organization or not? Now you need to assemble the team to actually implement and actually execute what you have planned earlier. So first decide how to position and name the security function. Now for the module, who is going to do it? And then what are the functions of the module? And then plan for proper staffing of the information security function. So let's say who will actually handle that particular function? Who will develop it? And then how you will actually monitor the progress of that particular stuff within that module. And then understand the impact of the information security across every role in IT. Meaning every module you have is important because you have a very big project and each of your team is perhaps handling a micro module or a smaller module from the bigger ones. So you must understand that one module depends on the next module, and then the importance of it must be understood by your staff that you are taking under you. So you must have a proper way to actually monitor the progress. And then how you actually do it. And then how do you actually enable each of your team members to understand it. Perhaps you have a weekly meeting or perhaps a middle of the week meeting and then to see the progress, and then you must address all the things that you want to that the management wants is properly addressed in your implementation. And then finally, integrate information security concept into the personnel management and practices of the organization. Meaning each people must understand that the thing they are handling within the project is an asset to the company. Even them, they are asset to the company, and they must understood whatever they are handling, whatever they are working on is part of a bigger organization, and each of those things that they are handling is an asset and of importance to the management. Each of your people must understood that they are important to the organization, and proper management practice and proper security implementation is important during each and every one of the implementation. Even the security guard is important. Even all the makcik and pakcik going in and out of your company is also important. So they must know that each of them, what they do in the company, okay, have a certain significant impact on the company's well-being and also the security of whatever you are planning for your asset and your company in the long run. So these are examples of InfoSec security professionals. And basically you have heard of this term before: Chief Information Officer, Chief Security Officer, Chief Information Security Officer, Security Managers, Technicians, Data Owners, Data Custodians, and Data Users. Each of these titles and roles have their significant impact in how you actually manage your security program. And then usually these are in the higher up of the organization. These are the implementer, and these are the technical and perhaps the end user within the scope of your system that you actually want to implement. Usually the higher ups will think about the policy and the politics of the organization. They see or they try to actually address whatever you are implemented is important, and usually this thing is to the people's person. They know how to talk to people. They know how to actually deliver in a layman's term or in a more understandable term. Why do you want to have this implemented? And then this one is the security manager and technicians. These are the technical people. And then the data owners, custodians, and users. These are the people that is on the field that perhaps is using and managing your system. Usually you will have the data owners, perhaps from users. You have data custodians, the one that is storing your data, And then you have the data users who will be using the data that you are actually managing and protecting. So it must work together. You must have people that can talk and can manage the project, meaning you must have the people's person, you must have the technical people, and you must have the, of course, the end users. Now, the CIO is usually the senior technology officer. His primary responsibility is usually to advise the senior executive on strategic planning. Again, you must remember the CIO must be a people's person. He must be able to actually address whatever you want to actually implement to the top management or perhaps to the stakeholder. Okay, he must be properly or will be able to talk in a layman's term to make sure that the management understood why is the implementation crucial or critical to the company well-being. And then you have the CISO. This is responsible for assessment management, implementation of the information security in the organization. So basically, whatever the technical or implementer is actually doing, he will tell the CIO, okay, these are the things that we need to done. This is what thing that we have done. Okay, so please actually deliver this to our top management. And then the CIO will talk to the top management and actually try to justify whatever they want to have delivered and must be delivered at all costs. So they must work together. CISO working with the implementer. The CISO reports to the CIO. The CIO reports to the stakeholder. Now we have security professionals and the organization that is needed to actually communicate with the people that will be using the system on the field. So we have wide range of professionals required to support diverse information security program. Usually you have people conducting workshop, conducting training. You have people in the HR and the admin. These are the people needed to actually working with people on the ground or in the organization that will be using your system. If previously CIO and CISO, they are working bottom up, meaning from them to the top management and the stakeholder. So for these people, they are working top to bottom. They are working with the client. They are working with the technical people. They are working with the users, layman users. So they need to actually address whatever needs to be done in a most understandable manner. If they want to actually provide training, they need to identify the people that will be using the system. Okay, because you also have security guards. You also have people or cleaner coming in and out that will be using your policy. So whatever you want to implement, it must be properly understood. Because if people don't understand what you need to do or why must it be done, then your policy or your implementation will not work in the long run because people do not understand the importance. Let's say right now, people don't understand why we need to wear masks, why we need to actually register before we enter. So the implementation must be properly understood and easily understood by the people that we are targeting, even technical people or normal people on the streets. Lastly, after all that is being said and done, it is the maintenance state in the SEC SDLC. So basically, this is the maintenance where you see whether the program is properly implemented. Okay, is it properly operated? Is it properly managed? Is it kept up to date? Do you have proper patching? So this is where you maintain and see the overall operation of the program or the module or the policy that you want to implement it. Does it address the previous threat and risk that you actually want to overcome? If not, okay, you must begin the cycle again. Let's say after 6 months, you see there is no improvement, although you plan to be like this, but perhaps there is no improvement. Okay, there are still data leakage in your operation. So you study again, investigate again, what is the problem, assemble again your team, and then see what the problem is. Because also during maintenance, you also get feedback from your people. So again, record every feedback that you have, go back to the investigation stage and see whether you can address those particular problem or not? If not, why? So these are the things that your team must think about, because this process is an ongoing cycle. It's not just one solution and you finish. It's actually an annual thing that you must keep on going and reviewing year by year, okay, until perhaps your system is not needed again, or perhaps you have a new system, but the process is the same. You begin with investigation, you begin after that with the design, implementing, maintaining, and begin again to improve or perhaps see the problem in the execution of the program. Now in this part, we have properly addressed the set SDLC phases. So you need to understand and relate these phases with the actual manner of the ISA, meaning it is a reactive and then also it's a proactive process. Proactively, you need to anticipate or you need to actually fix a coming threat and risk before it actually there. And then you need to do proper analysis and then followed by the design, implementation, and the maintenance process. And then overall, you must also remember the process needs to be supported by people. So understand what you have, who you have, okay, either in terms of hardware and software, and who will actually using this hardware and software. Do you have the capability to actually execute it? Do you actually have the capability to actually deliver it? Will people understand how to actually use your solution? That is the most important thing. You must understand your people, because your people will be using your asset. These people can also be your client. So throughout the process, remember the people, remember the process, remember the hardware and software, and also address your capability as honest as possible before you actually make the solution. Because if you are not honest with yourself, you may perhaps overshoot whatever you want to do, or you may not see properly the problem that you need to solve. So discuss with your team and then see properly each of the process and review it one by one, because this is an ongoing cycle. It's not just one phase cycle that you can stop after implementing. It is always an improvement year by